What's up, mathematicians? Today we are talking about partial quotients. If you have learned about partial products when you're doing multiplication, well, something similar is partial quotients. And this is a slightly different way of doing division. It's kind of like long division, but a little bit different. And in my opinion, I think that they should teach this in school before they teach long division. But you know what? Some places they do, some places they don't. Let's get right to it. Let's say we have a problem like 50 divided by 3. Well, this is how we set it up using partial quotients. First, we draw. So, in long division, we have this sideways L, right? Well, with partial quotients, we kind of do the same thing, but I didn't make that straight. We extend this side part. Then what we're going to do is we are going to put the dividend on the inside, just like long division, the divisor on the sort of end outside, just like long division, right? Now, this is what makes partial quotient, in my opinion, super cool. We work with friendly numbers or friendly number facts. And that's why I think that this is such a great way to learn division with larger numbers. So by friendly numbers, I mean usually multiplication facts that we know by memory, or numbers that are multiples of 10. So like, I'll give you an example. In this case, 50 divided by 3, I want to actually start by saying, how many times does 3 go into 50? Or what number can I multiply 3 by that is closest to 50 but less than 50? And it really, there's a number of ways that this will work, and I'll get to explaining that. But let's start with let's do 10. 10 is a nice friendly number because I know very easily that 3 times 10 equals 30. And similar to long division, I subtract. I subtract 0 from 0. 5 minus 3 is 2. And now I'm left with 20. Well, now I'm going to say to myself, okay, how many times can 3 go into 20? I can either use friendly numbers, 5s and 10s, or I can go back to my multiplication facts and say, okay, I know 3 times 7 is 21, so 7 is too high. But I know 3 times 6 is 18. Going to subtract. Again, 20 minus 18 I know is 2. And guess what? 3 cannot go into 2 because 2 is smaller than 3. So this becomes my remainder. I've now got a remainder. But what's the quotient? What goes up here? What's the quotient? Well, this is where it gets interesting. What I am actually going to do is I'm going to add everything I've written in this part. All these numbers that I multiplied 3 by. I'm going to add them up all together. I know 10 plus 6 is 16. And guess what? That's my answer. My answer is 16 with a remainder of 2. And another way to think about it is 6, 16 and 2/3, or you could just say 16 remainder 2. And there's my answer. Let's do a couple more examples so you get the idea of how partial quotients work. Let's do, 150 divided by, let's say 4. Just for kicks. Just randomly came up with that. Well, first I got to set the problem up. Make my shape here, my sideways L, but with an extended side over here. And I'm going to insert my dividend, 150, and my divisor, that's the 4. And make sure that everything's clear. And let's begin the process. Okay, so the first thing I'm going to say is how many times does 4 go into 150? But I want to use friendly numbers. I want to make this easy for myself. Well, 4 times 10 is 40. I could probably get a little bit closer to 150 using friendly numbers. If 4 times 10 is 40, 4 times 20 is 80, so we could do 20. And I could even go one more 10 more up. 4 times 30, I could say, and sometimes I write on the side when I really need to make sure I'm not going to make a mistake. And as you know, when you multiply by by a multiple of 10, like in this case 3 times 10 is 30, so we've got 0 there. Then what we actually do is we multiply the digits that don't have 0. 4 times 3, that's 12, and then we add the 0 at the end, or however many zeros there are in the factors, and we get 120. So now I've figured that out. So now I'm going to say, okay, I'm going to put 30 on this in this end here. 4 times 30 is 120. Going to subtract, and I end up with 30. How many times does 4 go into 30? Well, let me think using my multiplication fact. I could either do multiplication facts or I could stick to base 10. Let's say I want to just stick to base 10 or something really simple. I could just do a 5. Let's just do 5. 4 times 5 is 20. Let's say I just know my 5s really well. Well, what's cool about partial quotients is that as long as it all measures up, it computes anything that you put in this side column here that you're going to add up will work. It doesn't have to be exact. You can just keep going and going until you end up with a remainder of less than the divisor. 30 minus 20 is 10. How many times does 4 go into 10? It goes in twice, because 4 times 2 is 8. Subtract, I get 2. How many times does 4 go into 2? Well, it doesn't, because 2 is less than 4. So we have got our remainder. Now I just do the last part of my problem. I add 30 plus 5 plus 2. 0 plus 5 plus 2 is 7. And then we've got the 3. My answer is 37 remainder 2. Or 37 and 2/4, but 37 remainder 2. Not so bad. Now, what if we have a really big number? What if we have, or a complicated one? What if we have 171 divided by, well, should we do double digits? You know what? For now, we'll keep it simple. Let's just do 5. 171 divided by 5. So it'll be our last example. First, I need to set up the problem. 171 divided by 5. You can see sometimes I write my 7s with that little line. You know what? It's a force of habit. What can I tell you? And let's get to it. I'm going to say, okay, 5 times 10 is 50. I could do 50. Let's just do 50. Let's keep to friendly numbers. I could also say 5 times 100 is 500, but that is too big. That's greater than 171. Let's just do 5 times 10, which is 50. 1 minus 0 is 1. 7 minus 5 is 2. And 1 minus 0 here is 0, but we don't need to write it. Now I'm going to say, how many times does 5 go into 21? 5 goes into 21 4 times, because 5 times 4 is 20. 21 minus 20 is 1. 1 is less than 5, so we've got my remainder. And now the last part of the problem is I just need to add everything in this whole side area up. 10 plus 4 is 14. There's my answer. 14 remainder 1, or 14 1/5. And that is an introduction to partial quotients and doing division using partial quotients. And we will also learn how to do partial quotients with decimals and larger numbers. And hopefully you like this method as much as I do. Till next time.